today we're going to work with lesson 11, and this is solving equations with radicals. And with these, we are also going to have these extraneous solutions again. So as a reminder, these are solutions where you've solved the problem mathematically correctly, but when you plug it back in, it actually doesn't create a true statement from the original equation. So let's take a look at this first one. And when we solve this, the first thing we're going to do is we're going to get rid of the square root. So I'm going to square the left-hand side, and then what you do to one side, you have to do to the other. Squaring the left only undoes the square root. It's not going to do anything to the radicand. That would stay exactly the same. And we equals x squared. Now from here, it's just a quadratic equation. Right? We're going to take everything to one side, and then we're going to decide what method we want to solve. So I'm going to take everything to the right. And then from here, I'm going to choose what I want to do. Square root method is out, but I could see if it factors. I could complete the square. I could do quadratic formula. It's really my choice. I can tell that this factors, so I'm going to go with factoring, and I know that it's going to be an x plus 3 times an x minus 1. Oops, actually, I have my signs backwards. Try that again. Well, it won't let me erase. Okay, well, this is going to be minus, and this is going to be plus because my eraser is not working. So then you set each of these equal to 0 and solve. So I'm thinking that I get the answers of x equals 3 and x equals negative 1. Now here's the additional thing that you need to do with these. We need to check them. So the reason we have to do a check is because equations with radicals often have an extraneous solution. So if I check x equals 3, I'm going to plug in 3 for each x in the original equation. Well, if I simplify that radicand, 2 times 3 is 6, plus 3 is 9. And I know that the square root of 9 is 3. So my x equals 3 is definitely a solution. Now, what if I check x equals negative 1? Plug it in. And I can already tell I'm going to have an issue because a square root cannot produce a negative answer, right? I am not square rooting both sides on this one. I am evaluating the square root on the left-hand side. And when there's no symbol in front of a square root that's already printed, it is presumed that you want the positive solution. So if I simplify the left, I'm wanting the positive root of 1 if I simplify inside there. That's not going to give me a negative 1. Okay, so that means this x equals negative 1 is not a solution. It is extraneous. So you have to check each of your solutions to see if yes, they work or if they are extraneous. Now let's try a cubed root. It's really the same concept. To undo a cubed root, I'm going to cube both sides. And again, cubing both sides is just going to undo the radical, and the radicand is going to remain exactly the same. Add 3 to both sides. I'm thinking that my answer is 11. But I'm going to do a check. Make sure it's not extraneous. The cubed root of 11 minus 3, we're hoping, produces 2. Well, that would be the cubed root of 8. That is 2. So I know that x equals 11 is my solution. The last one that we're going to do today is this, and this is where you have a 1/2 power. So it might seem like you've not seen this before, but you have, right? A 1/2 power is a square root. So I could think of it like this. I don't really need that in parentheses. Let's see. My eraser still isn't working, so we're just going to go with it. You don't have to write it in the square root form. It's up to you. But we're going to undo it the same way no matter what. I'm going to take that left-hand side, I'm going to square it. And I'm going to take the right-hand side and I'm going to square it. Remember, squaring or power to a power is just multiplying. So that would give you 1. So this is just 3x plus 2. And then remember, on the right-hand side, you have a binomial squared. So I need to multiply out x plus 1 times x plus 1. And when I multiply those together and combine my like terms, I get x squared plus 2x plus 1. Now we're at a quadratic. I'm going to get everything to one side and then decide on my method of solving. So if I take the 3x and the 2 to the right-hand side, I end up with a x squared minus x minus 1. I can't do the square root method. This particular one doesn't factor, and b is not even, so I don't care to do completing the square. You could, but I don't want to do it. I'm going to do quadratic formula. So we would have 1 plus or minus. B squared would give you 1 minus 4ac all over 2 times a. From here, inside that radicand, as long as you keep control of your negatives, you're going to see that you get, my screen doesn't want to work, the square root of 5 over 2. Now, that doesn't simplify any further. And when we solve these, you are going to give me exact answers, okay? But with this, when we do a check, you can go ahead and use decimal answers for a check. And here's the only catch. When you plug in decimals, it's not the exact answer. You are rounding. So your checks may not come out to be exactly matching, but they should be very, very close. If I'm going to check 1 plus the square root of 5 over 2, I'm going to use a calculator, okay? And you can type it all in at once if you put the numerator in parentheses and then divide it by 2, and you would get 1.62. And there's more decimals to that, but I'm going to round to the hundredths place. So if I plug that into the original problem, I have 3 times 1.62 plus 2 to the 1/2. I'm going to see if that is equal to 1.62 plus 1. And again, use a calculator, right? Follow your order of operations, or if you type it in exactly as you see on the screen, if you're going to keep your exponent a fraction, though, you're going to want your exponent in parentheses as well. And if you do that correctly, the left-hand side is 2.62 and the right-hand side is 2.62, so we know that that one's good to go. Now let's check our second answer. If I do x equals 1 minus the square root of 5 over 2, its decimal form is a negative 0.62. So let's plug that in. 3 times negative 0.62 plus 2 raised to the 1/2 power. It's going to equal, I'm going to run out of space, and plus 1. And if you put that in the calculator, what you're going to end up getting is you're going to end up getting negative, or 0.37 equals 0.36, or 8. Sorry, that's an 8. So even though those aren't exactly the same, we know that we rounded. So we're going to call this one good, because if you're off by 1/100th, it's probably due to rounding. If you're off significantly more than that, then that would be an extraneous solution. So here, both of these answers work, and so you'd have 2 solutions for this one. And that's what we're going to do today. We're going to do more of these in our next lesson, but we're going to get really good at these before we amp them up a little bit more.